So let's start with the lecture now. So this lecture will be, I guess, probably the last one where about like introduction to C++ in terms of starting from next week on. I expect that we start seeing like more heavy and dense C++ code. But I really want to take the proper time to allow you guys to start up your coding expertise in C++. So basically what we're going to see today is what I call the legals. So it's basically nothing more like nothing else than just what you can do and what you can't do in C++ in terms of writing the program. Is it possible to provide the lecture PDF before the video? Yes, it is. Not now. Sorry. Next time I will do it. Sorry, there was a question if there is a chance to get the lecture PDF before the video. Okay, thank you. So the idea of this lecture is that you will have a brief understanding of what you can do, what you can't do, and also I would like you to point where you should be looking for references in order to get the proper ideas. So not much coding in this lecture. There will be a lot of rules, so people who likes math, they will probably enjoy this lecture. Again, if I need to explain you probably all the rules of the language, it will take me some time. And actually, I guess that the only ones who really knows all the rules are the people who work in the standard committee, like people who live about C++. So not everyone knows exactly all the rules, but I just wrap the rules you probably need to know. Okay, let's start. So here's a definition of what we think that is a C++ program. So it is basically a sequence of text files that are this .cpp and .h or HPP files that contain declarations, right? And they undergo a translation to become an executable program, which is executed when the C++ implementation calls its main function. So let's see some of these definitions. Again, you will not gain any coding expertise if you learn these definitions, but it's really good to know. So first of all, I will show you a table, but what is a C++ keyword? So it's really good that if also when we speak, we try to use this terminology. So the first slide is basically a glossary on what are the terms in C++ programs. So some words in a C++ program will always have a special meaning, and the name of these words are keywords. That this is true for all languages out there. Or it can be used as identifiers. Comments are always ignored during translation, so certain characters in the program have to be represented with escape sequence. So basically, I put there some examples, but words like const, auto, friend, false, etc., etc., etc. are C++ reserved keywords, and this means that you shall not be used these words for anything else that is not the purpose of this particular word. Again, we saw some comments, but basically there are three types of comments. So it's I put there the comments you can do on your code. Again, I highly recommend you that you don't base your programming expertise on comments, but in code. So the idea of C++ is that we can write the intent of our programs in the code itself, and then we can avoid some comments. And then the sentence that says something about the escape sequence. So basically, this guy right here. So the /n is basically what is called an escape character, and there are many of them that are like specific characters that we call it escape sequences. So these are like basically C++ keywords. So these are words that you cannot use for your own reasons, are reserved by the language. Then there is this concept of entities. So the entities of a C++ programs are basically values, objects, references, functions, you name it. Preprocessor macros are not C++ entities. So this is just, again, it's just a dictionary of like what are the meaning of these words. The idea of these slides is that you have a small reference on the topics I think you should be paying attention, but of course you can go to the books and the C++ reference standard, and then you get much more definitions. So for example, the first line, like 3.5, so this is a value entity, so this corresponds to this guy, and then this is an object entity because we will see later on, but basically string is a class, so this is an instantiation of this class. And then for example, you can have namespace, entities, etc, etc, etc. The only thing that is not considered an entity on a C++ program is preprocessor macros. That this is basically inherited from C. So this is not considered a C++ entity, and there will be some consequences of this, of course. So this is basically the definition, nothing to worry about. And then we have the idea of declarations. So declarations may introduce entities, and now you know what is an entity: a value, an object, a reference, etc, etc. Associate them with names and define their properties. The declarations that define all the properties required to use an entity are called definitions. So basically, in this case, we have this statement here. It's basically introducing a new entity that is named foo, right? And then this other statement will introduce a new entity that is a function entity that is called my function. And in this particular case, because we have all the details of the implementation, so basically we are defining all the properties required to use the entity, that in this case the entity is called rate function, then we will call this a definition. So if you remember, so far we have been dealing with build systems, and one of the exercises we had the header files where we had declarations, and we had source files where we have the implementation of these function entities, and then that's why we call this the definition, right? So these are like just words, and it's good to have an idea of like, okay, this is a declaration, this is the definition. So when you talk with other people, or actually when you also ask questions through the channels, you know like which are the words you should be using. So definitions of functions usually include sequences of statements, some of which include expressions, and this is another keyword. Sorry, it's not a C++ keyword, but it's a concept itself, which specify the computations to be performed by the program. Again, this looks like the Bible of C++, just definitions, but basically this is the idea of what is a definition. So basically it's a bunch of statements and expressions. So something that it's really important is that every C++ statement will end with a semicolon, and people who's used to Python or no MATLAB, I think you also need it. And other languages, just don't forget this, or otherwise your program will not compile, most likely. And then this is a statement again, so we are reusing the same examples, but there are a lot of information behind each line of code in terms of what is each line. And then, for example, in this case, a plus b is what is called an expression, right? So basically, this is the definition of an entity, of a function entity called my function, and includes sequence of statements. There are basically these three statements, some of which could include expression, and the third statement will include this expression that is the sum of a and b, right? So this is how this is the definition of a definition in C++. Really fun, no? And then we have names, right? So names encountered in a program are associated with the declarations that introduced them. Each name is only valid within a part of the program called its scope. So this is a concept that I will be trying to highlight during all the lectures. That is the scope of a program, the scope of a function, the scope of the namespace. So something that is really important is that you know that these curly braces or brackets, this will open a new scope no matter what you have on top of your head. So for example, here you can have a namespace declaration, a function declaration, you name it, but or probably nothing, like in this case. So this is legitimate C++ code, so this will compile. This will create a new scope, and basically that's the whole idea of lifetime of variables and objects in C++, is that the objects will only be valid within this scope. So in this case, so my variable is the name of this entity, and then in these 3 lines I'm opening a new scope, and then I will create a variable, right? So this defines a new scope, and then the variable is valid only within this scope. This means that if I, for some reason, try to access this variable outside this scope, this will fail. So actually, if you try to do this, you will get a compilation error, and this is due this variable is not visible in this scope, right? And then, for example, if you want, you can rename, you can create a new variable with the same name and probably with another type. And this is valid because in this scope, that is the global scope, this variable var fl is not declared. So this is valid. So even perhaps I might forget at some point, but I will be trying to really pay attention to the scopes of the entities in C++ programs. And then we have types. So this is probably the most important concept in the C++ glossary, that is types. So big part of our course will be dedicated to this. Basically, each object, reference, function, expression in C++ must be associated with a type. So C++ is a strong type language. If you don't know the meaning, just don't worry. Which may be fundamental, compound, or user-defined. And also these types could be complete or incomplete. So which are the fundamental types? Basically the built-in types of the language, like floating point, boolean, integer, all the types you expect. And also user-defined types. It's basically my type. It's a type that I define it, for example, or you define it. So the idea of this is, behind the scenes, this is a class. So we will reach this point probably in 3 or 4 weeks. But basically, the idea of C++ is that you can create your own types, and then you can express the intent of your program much better using your own type system. And I will show you some examples when we reach this point of why this is a great idea for everything. And in this case, this is what we call incomplete type, because here is just the type declaration, but there is no definition. So if you don't know what a definition is, you go back to the slides and then you read the definition of definition. And in this case, because I have all the details of the implementation, we will call this, that is a complete type. It's not really relevant that you know this, but it's good to have an overview of the key concepts. And then lastly, we will have C++ variables. That what is a variable is basically all declared objects and declared references that are variables, except for non-static data members. So you will probably really get the idea of this sentence in 3 or 4 weeks. But for now, you need to know that basically this is a variable, this is also a variable. In this case, I am creating a variable of my type, so a custom defined type, and it's also a variable, but it's also called an object instantiation of the class. And then, for example, let's say that this class has a static data member. Don't worry, we will see this in 3 or 4 weeks. This is also a variable. But if you want to access a non-static data member of this particular type, then this is not specifically a C++ variable. Yes, we will recap this in a few weeks. Also keep in mind that when you create variables or types or functions, you will need to give names. How do you do this? Using identifiers. So an identifier is an arbitrarily long sequence of digits, underscores, lowercase and uppercase Latin letters, and most, but not all of them, Unicode characters. A valid identifier must begin with a non-digit character. Identifiers are case sensitive. So basically, this is the names you will pick for your program and the entities on your programs, wherever these entities are. Namespaces, functions, classes, variables, etc, etc, etc. So in this case, these are all examples of valid identifiers, except for one. So I will highlight you the one that you can't use, and this is not because I don't like it. This is illegal in C++ for many reasons, besides that it looks ugly. So the only thing you cannot do is start the identifier, so the name with the digit, like a number, right? But you can also use Unicode characters like this guy. Of course, if you do this, you will most likely struggle, especially if you use like weird characters, because depending on your system, you will be able to see this or not. So of course, no one really do this, but in case you really want, you can actually do it. So if you go to the reference C++, you will find like a list of all the Unicode characters you could use wherever, but it's much easier to just use letters. And also these are case sensitive, so this identifier is not the same as this one, because we have a capital S and we have a small s, so these are not the same identifier, thus they are different entities. And then lastly, you can do whatever you like. Of course, this is considered valid, but it's probably way too long for one identifier, so just behave properly when creating names. And here are basically the table with the list of keywords in C++. What is the meaning of this? Is that you cannot use these keywords in your identifiers, right? You cannot call a function or create a variable and call it, I don't know, what is friend. You cannot do this. You will have a compilation error because this is a reserved keyword for the language. You don't own this word, so you cannot really use it. So of course, whenever you program, you never have this at the top of your face, like trying to see, but keep in mind that you cannot pick any word in English for your identifiers, right? Then when we so if we go back to definitions, we say that definitions of functions usually include sequence of statements, some of which can include expressions. So basically, an expression is a sequence of operators and their operands that specifies a computation. I put here basically a list of all the operators you can use in C++. Some of them are like really, so we already know this and we expect this for the language, like the sum operator, but as well we have like super good stuff like the increment operator, that of course will be different if you do this. If you go and check the documentation, you will find out why. But basically this adds one element to the variable a, and this is the idea behind actually the name of C++. So basically C++ is C plus 1, so it's a bit more than C, and that's why the name came into place. And nowadays people got really excited about this plus thing, and you will find people putting plus everywhere. I'm a bit tired of this plus movement, but I don't know. So C++ was like a smart choice to do 40 years ago, but if you plan to do something or you plan to create something, just don't overuse the C++. It's annoying for me, right? So these are basically just a list of common operators you can use, and these are the ones you could use in order to make computations in your program. So you have input data and then you want to do something with this data, and these are the operators that the language will provide you to work with that data. Probably next lecture or 2 lectures more, we will see how to work with these operators in a C++ way. that this basically is how to overload these operators and make usage of the C++ language really good. Okay, so that was basically the glossary. That means that whenever you struggle with probably something that you don't know how to write or something like this, it's probably a good idea to check the slides and see the what are the legal things you can do or you can't do, right? If the information you're looking is not in the slides, then you will go to CPP reference and then you will search there and then you will probably find the answer. So we will go super quickly now on control structures. And why? Because I sort of expect that you know this. So these are like basic techniques and ideas on programming. So this has nothing to do with C++ itself. And this means that there are no new ideas introduced by the C++ language for control structures. Yeah. So basically the idea of this will not change if you're using Java, Python, C++, C, Julia, R, whatever. So these are basically core techniques on programming. And if you really have no idea about these structures, then it's probably a good idea to go and search for an introduction to programming course, right? So this is not something that we will spend a lot of time explaining because it's basically easy stuff. The only thing I want to show here is the syntax of these structures. So we have the famous if statement. So basically you can have a Boolean variable and ask if this variable is true or false, and depending on the content of this variable, you can execute some actions or not. So basically, if today is rainy, then I will do this. Else, if it's sunny, I will do other thing. And else, if not, neither both of the one we said before are true, then we will do this. So that's basically an if statement. It's the same as any other language. The only difference probably is the syntax. So if you compare with Python, for example, in this case, we don't have like the forced indentation system. So whenever you open a new control structure, these if statements will apply to the new scope that is generated when you open curly braces, right? So basically this is what is inside this if statement. So this is what will be executed if the statement is true, right? In Python, you do the same, but with indentations. So in this case, you can write everything in one line. Of course, it will look ugly. But yeah, the only difference between, so how to put stuff in different parts of the structure is with curly braces. So with these curly braces, right? So this is simple, it's just the syntax of the language. Then we'll have switch statements, as most of the language have. So basically this is used to conditionally execute some code, and then we can have many case statements, and then just keep in mind to use the break. So usually this is something really easy to forget. So if whenever you hit this case, after you execute whatever, it's part of this const do to case, then you will need to break the execution of the structure, otherwise you will run into default and whatever you have here. So just don't forget to use break whenever you use switch statements. And then usually this statement could be an int or an enumerated value, right? So let's see a really small example. And in this particular example, I'm kind of lying to you because C also has enum types. But I just wanted to show you how a C programmer will probably handle this task, even if they know that there is enum types. This is how they will do it. This is typical C code, and besides it's a bit ugly, there is nothing wrong with that. But basically in this case you have a color variable. Let's highlight this. There is this guy that is an integer, right? And there are two main problems with this. Again, you can actually improve this in C, but it's very likely that if you know someone who knows C will do it like this. So the first problem is comments, right? I have been telling you that our idea is try to avoid unnecessary comments. And then color is not really an integer variable, right? It's a color. But besides that, now you need to give an explanation or on what is the intent of your program. You need to say, okay, red will be 1, green will be 2, and blue should be 3, right? This is a really small example, but what happens if you change this definition? Probably you forgot to change it in the code, in the comments. And then your whole program will be a mess, and these are really hard bugs to debug because it's part of, it's not really wrong, but the intention is wrong. So this is the first thing we would like to remove. The other thing is that color is an integer value, so it can be 0, 1, 2, 3, 4, 5, wherever. So it's not really safe. And then we will see with the type system of C++ in future lectures how to fix this kind of issues. But you can, the idea is that you start to develop an intuition on what is like C style code or all style code and C++, right? In this case, the intent of the program is not really specific. It's not really visible on the source code. Of course, you compile it, you run it, it works. I'm not saying that it doesn't work, but the intent of the program could be much better expressed using C++. In this case, we will be using something that is enum class. We will give more details on this in future lectures, but it's basically, we will create this new type and then we will say, okay, this type can assume 3 values, red, green, and blue, right? And then we will create a color that is of type RGB. It's not an integer anymore. So now we cannot put a 4 into this color, and then we are already avoiding mistakes. And also here, the intent of the code is visible because RGB could be red, green, or blue, and that's all. I don't need to add any extra comment saying whatever you're reading is what it is meant to be, because the code itself speaks by its own. And then this is basically the same switch statement, but instead of using an integer, we're using an enumerative type, right? And then if the case is red, then we will print red and blah, blah, blah. If you compare it with the example, the C example, you will see that actually the case here, we were forced to use numbers. And then here, so if I change this definition, I need to remember that I also need to change this part of the code. So this will be probably a mess, right? So it's really good for me. I will be really proud if you start developing this intuition on what is C++ and how to write good programs. Okay, continuing with control structures, we also have loops. So we have the famous while loop. So we have a question that is the object of version. I don't get the question, but we can discuss it offline. Yeah, don't worry about the syntax of enumerative classes. Yeah, I know you can use enum with C, but this doesn't mean that people who program in C knows that they can use it, because I've struggled with a lot of C programs and most of them doesn't use it because it's better because it's too high level, and then they keep track of what's going on and then they just don't use it. They prefer integers or chars or whatever. And not all of them, but most of them. So don't worry about this syntax right now, because this is part of the enum class types that we will discuss it later on. The idea is that you see that if you read this code, even if you don't know C++, you kind of get the idea of what's going on. So but don't worry about this particular example, because we will discuss this later on. Okay, while loops. Basically, wherever you want to loop, you can use a while loop, and then this will be the statement is usually a Boolean variable, and then while this is true, the loop will be executed. So make sure that you use this wisely, because it's really easy to end up in infinite loops with while. And then this is another example. Again, I'm not planning to do examples like live code examples on this, because it's something that I expect you to know. And if for some reason you really struggle, just send me an email and then I will try to help you to find a solution for that. Then there is also for loops. This is usually the loops, like the most used loops in C++. That basically you will have an initial condition, an end condition for the loop, and then you have an increment part of the loop. So basically, let's say that you want to do something and then you have a variable or a const variable that is count, and then you will iterate this many times, and in each iteration you will increment the I variable that is nothing more than an integer that is initialized in 0. So this is nothing more than a for loop, right? But the thing is, in C++, starting in C++ 11, we also have like better loops that is basically range loops, it's called. So we will discuss containers next lecture or in 2 lectures. But basically, if you have a container, don't worry if you don't really know what is a container in C++, but it's a collection of items, of elements, like an array of, I know, floating point values. And then you want to iterate through these values. You don't really need this auxiliary variable that is called this I variable. So if you want to iterate through a container and, I know, print the values, the I variable is not really needed. You don't want it. It's redundant. But before C++ 11, you had to do it because the language didn't support range loop. So the idea of a range loop is that whenever you have a container, you can iterate through this container with the for syntax, but without specifying this auxiliary variable. So basically, in this case, so you have a container, and then you will have one value for each iteration will be part of the container. Whenever we see STL containers, we will see a lot of examples on these for loops. So is this a for each loop? Yes, this is a for each loop. So this is also range loop is also called for each loop. And thanks for the question. It's actually good. Because actually you read it like for each value in container, blah, blah, blah. That's why the name for each. So in this case, let's pretend that container is, I know, a list of names, like bunch of names that are strings. And then you say for each name in names, and then you will, I know, see out name. So this is actually really easy syntax to read and express the intent of the program much better than a for loop with an I variable. You say, okay, I have an I variable and blah, blah, blah. And I don't need it, right? And also, spoiler alert, don't worry if this looks misleading to you. It's something we will cover in future lessons. But there are some stuff in C++ 17 that is actually new, and that this is one of the reasons we are using this particular standard, is that you can use dictionaries and you can iterate through these dictionaries in a Pythonic way, right? So small example, basically forget about this type, but we are creating a variable called my dictionary that has like these two members, right? And then we can iterate through this dictionary with really simple syntax that is a for each sentence. So for each key and value in this dictionary, then print the key and the value. So this is basically the key. Will be in this case A, and this will be the value. So on the first iteration, you will have like key A has value 27, and the second iteration you will have this guy. Before C++ 17, you had to do much more steps in order to print the same results. You can actually, I mean, you could do it. It's not that this is new, but it's a matter of syntax. And this is basically the equivalent in Python. So this is how you will do it in Python. And why I'm showing you this is because most of the people are really scared about C++ because the syntax is a bit more complex than Python or other languages. And that's why usually most of the people end up using more simple language. But the idea is that with the years, the C++ standard is trying to improve its readability and its usage of the language. So with this, I want to show you that you can do the same in Python, but in C++. And spoiler alert number 2, if you run these programs on your machine with the right optimizations, you will find out that the C++ implementation it's about 15 times faster without doing anything. So the price you pay is nothing. There is 2 more characters involved in the program, but it's like 1 more line compared to 3 lines. So it's almost the same syntax. So the ideas are expressed in the same way, but you gain 15 times performance at runtime. So this is one of the reasons C++ is still used nowadays. And then this is not something that you should be using unless it's necessary, but with a break statement, you can break the execution of each of these control structures that we saw before. So let's say you are doing an infinite loop on purpose, like while true, and then you will compare some conditions, and depending on these conditions, you can break, and this means that you will stop the execution of this particular loop that is defined within this code, right? Of course, this is not considered structured programming, so it's not highly recommended that you use this unless it's necessary. I'm not saying that it's wrong, but there's usually a way to avoid this kind of techniques that will give you headaches and bugs in the future. Okay, so reaching the end of the legal parts of C++, we went through the glossary, we saw some control structures, and now I will show you some of the built-in types. So these are what we call out-of-the-box types in C++, that are basically types that are already there for you. You don't really need to do anything to use it. So basically, these are examples to this point. So these are all built-in types. Make sure you go and check the reference. You will see a lot of types, but the idea is that these are types that you can actually use. And then also we will start using a lot what is called automatic type deduction in this case, but we will explain this in more detail in the future. But basically it's like you have a variable that you know that is a floating point variable because you're specifying this with this f, and then you don't really need to repeat the name here, so the compiler can deduce this type for you, and then in the future, in the long term, it will make your code more readable. You will see why in future lessons. So there are a lot of operations that you can do on arithmetic types. Remember, if you want to see what is an operation or which one are the operators you can use, go back in the slides and go to the operations, and you will see the table with all the operations. But you can do arithmetic operations, comparisons, you can increment operations, you can do a lot of stuff with these arithmetic types. Basically, which one are the arithmetic types? Go check the reference before, but it's characters, integers, and floating point values. This could be short, long, double, floating point, unsigned int. A lot of like all these types that are part of the core language are considered arithmetic types, and then you can use all the arithmetic operations with these types, right? And one big advice, because it's very likely that you will feel the temptation to do this during the lectures, is avoid using the equal operator for floating points. If you really want a huge explanation on this, I can do a 5 minutes video, but it's a matter of like the implementation details of floating points. People who have a strong background on computer science will know how to represent floating point values, and then you will probably have a sort of intuition why it's not a good idea to compare floating points, because no matter what you see in the source code, the implementation, the bits that represent these floating point values might be different, right? So keep in mind that it's never a good idea. Okay, so this is an example of why it's not a good idea. So if you try to run this program and then you compare the results, okay, spoiler alert, of course this is false, otherwise it wouldn't be here on the slides. Anyway, you can also do some additional operations. Like with Boolean variables, you can do the OR operator, you can use the AND operator and NOT. The syntax is the inherited from C. So it's, if you know C or Java, I think the syntax is the same. And basically you can do some operation, like for example, if it's not hungry and it is warm, or if it's rich, then the Boolean variable is happy will be true. So this is some examples on what you can do with operations. And just the only thing I would never recommend you to do is doing stuff like this, that basically this is legal C++, you can do this, but of course if I give you two numbers for A and B, two integer numbers, you will most likely give me the wrong answer for this. So just keep in mind that whenever you use these increment operators, just make sure that you don't do this crazy stuff, because it's impossible to know what you're trying to do. Okay, so variables, we already talked a bit about variables. So there is always a pattern, like you need to specify the type, because C++ is a strong type language. You will pick a name for this that is also called the name of the entity. You will use an identifier for this, and then optionally you can initialize this variable. So it's always a good idea to initialize your variables to have a consistent startup state of your program. Then for naming variables, so we already discussed, this also holds for any identifier. The name must start with a letter. You should try to use meaningful names. And then this is something that we will be seeing through the slides. I'm not a huge fan of the Google style, but of course it's always a good idea to have some style. And in this case is to use snake case for variable names. And why it's a good idea, because if you're reading a huge C++ program and then at some point you find some variable that is written on snake case, then you would probably know that it's a variable without going and look for the declaration of the variable. So that's the idea behind the styles, is to give more information about your program without having to know all the details. So that's basically it. Also, we already discussed this, but variables will live in scopes, so the variable belongs to the scopes where it had been declared, and all the variables will die after they reach the end of the scope. So how to learn this by heart is basically just opening the text editor and writing some examples, try to manipulate variables, declare it in some scopes. I don't know, have fun with it and try to learn that the variables live within the scopes that have been declared, right? And then lastly, any variable can also be const, and this is basically to protect the programmer of changing the value of the variables, right? This is also key concept in any other language. Basically, if you declare a variable const, the compiler will guard it from any changes. This means that once you declare, you give a value, and then you cannot change. If you attempt to change it, then you will have a compilation error. So this is before runtime, right? And the Google folks thought that the best way to name this variable is using camel case and started with a K for constant. And then this is something that you will see in C++ programs. Like you see this and then you say, okay, this is a const value, so I will not attempt to change it. So that's basically it. And the tip we always give is declare everything const unless it must be changed. So if you are declaring a variable and then you don't really know if you need to change it afterwards, then just do it const, because it's better for the program itself. Then we can also use reference to variables. And for this, it's basically a reference to a variable. It's a way to accessing this variable. It's a fast way to access this variable. Let's put it like this. We will see pointers and memory management at the end of the course, so don't get too excited about this, but basically a reference to a variable is a reference to that variable. Keep in mind that the reference is part of the type, so in this case This is a type of the variable ref, so it's a floating reference, floating point type reference. And then whatever happens to this reference also happens to the variable because it's just a reference to that variable. And this will give you performance because you can avoid copying data. And we will see this in the next lecture. Here is an example how to use const with reference. I will highly recommend you to go check it out, compile the example and run it. Okay, and then, so for now we reached the end of the legal part. That is basically the glossary, the built-in types, the control structure, and some ideas about variables. There is no real heavy concepts involved on all these things. And then I thought it wasn't super fun enough, so I added like small. We will see a small example on something that is not related to the legals. So now we will see how to use string streams, and then this is a technique you will be using on your homeworks, right? So this is taken from lecture 0. These are basically some IO streams that we already saw. That is basically the cout, the standard input, and the error. And this is also part of the C++ standard library. And then, I'm sorry, C programmers, but this is, I would like to be on the classroom now and see who can guess what's going on here, right? But basically, if you build this program, but actually, if we have time, we can do it. So if you read this program, it's almost impossible to read. It has been a while since I programmed in C, and then probably I'm not the best C programmer, so I should ask some C expert to rewrite this program to make it the best possible. But if you see the program itself, it's not really easy to identify what's going on. But I will tell you what's going on because I wrote the program and I know the intention. So let's pretend that I have a file name. That actually this is probably a data set that I will have a bunch of file names, and I have this file name. And the idea is that I really want to split this file name in two parts. I want to get the identifier for this file that is going to be an integer, and I want to know the extension for any given reason. And then the way of doing this on C is basically traversing the string and looking for patterns, right? One of the disadvantages of this is that it's a bit funky, and also it will be really hard to split these two types that are basically two types in different variables. But if you print this, you will see on the standard output, you will see this string. So you will see 00205, because right now you're printing only strings, and then you will see the second string that is .txt. But actually I want this 205 to be an integer, because for me this is not a string, it's not a word, it's a number, right? And of course, if you move to the C++ world, you can use something beautiful that is called string stream. And if you actually spend a few minutes trying to read this program, besides if you are used to the syntax or not, you can actually guess what is the intention of the program much better than the C counterpart, right? So basically, we have the same variable that is file name is 00205.txt, but then we can split the information in this string in two variables, right? One will be integer and the other one will be a string, because that's the thing I want to do. And how you do this is using the streams operator that basically are shift operator overloaded. Don't worry, we will see this soon. And basically with this operation is defined on the IO stream library, part of the C++ standard library, and it will split pre-formatted variables. So in this case, it's really clear that you have an integer here and the rest is a string. So let's do it with different colors so you see it. Look here. So this is really handy to use. Of course, if you do the other way around, you will have issues because you first have, so you traverse the string. That's why it's like a string stream. from left to right, and then the first part will be an integer and the second part will be the string. If you try to change this, you will get errors, right? Of course, if your string is the other way, like it's, I know, like txt and then dot and the number, then you need to do file name, then the operators, extension, and then the number. And then one of the benefits of this is the type. Now the number is an integer, and I can do arithmetic operations with this number because it's not a string. Of course, a C programming will tell me, oh, you can use a string to integer, but then you have an additional step in order to convert the string 00205 to just 205. So we will run this program and we will see that basically this number will be a number. And no matter what, you can do a lot of operation with that. Let's say you have a database and then you have a bunch of files with this format, then you can, I don't know, compute whatever with these numbers or something like this. Let's pretend that you want to only process the files that ends in txt and not the png files, for example. Then you can distinguish using the string x. You can compare if there is a png or a txt file and take some action on that, right? And this is like what I want you to start developing this intuition. This looks much better. It runs at the same speed of the C counterpart, and it's easier to read, it's easier to maintain. Because if you, for example, I know, add some other part on the stream, you just need to add one variable and that's it, and then you don't need to post-process all the steps, the manual steps you did with the C part. So again, this is the C example, and this is the C++ example. So actually, let's go and check it out. This. Okay, so the streams. So we don't have much time, so I will just copy the examples. This guy, and then so I will open a text editor here, and we will just run the programs, like build the programs and run it to see the output. So first we will see the C example. So this is taken from the lecture slides, so there's nothing really funky here. Oops. And then for this we will use GCC, or Clang is the same, and then we will compile just main.c. It's called stroke, sorry. So GCC stroke.c. And then we have the executable, and then we have this. So we have, is this big enough? I don't know. We have 00205, that this is a string, and I don't really want the first two zeros because I only need the integer. But with C, it's really hard to split these two types. And then I have the txt extension, right? And if you compare it with the string demo, with the C++ counterpart, when you run this, you will see the same output, but it's much better. So for that, we will use clang++ and then main.cpp. Stream. And then when we run the executable now, we will have number is 205, so it's not a string anymore, and then .txt is extension. So this is a small example. Make sure that you run it on your computers. So ideally, on future lectures, most of the lecture will be focusing on programs, and I will try, whenever I remember, to show you a C example or any other language example on how you will do it on this language and why we C++ programmer thinks we can do it better with C++. Not because we are better programmers,